Hi, everyone. Thanks for joining us today for what will hopefully be a very exciting and engaging introduction to Planet Analytic Feeds. Let's kick it off with an introduction to our host for today. My name is Jenna Macuno, and I'm on the product marketing team at Planet, where I work very closely with my co-host, Justin Davis. Justin, I'll let you introduce yourself.
Hey everyone, I'm Justin Davis, and I'm a product manager working on our analytic feeds, so using machine learning and computer vision to make it a bit easier to work with our massive imagery catalog.
Cool. Justin, how long have we been working on Planet Analytics Feeds together?
Oh, it's got to be close to 2 years now, or like roughly 5 or 6 petabytes of Planet imagery, or maybe 8 or 9 rocket launches.
That sounds about right. I'm also excited to introduce a special guest, Asa Strong. Asa, would you like to introduce yourself?
Thanks, Jenna. Hi, everyone. I'm Asa Strong. I'm a product manager for Planet integrations into certain JS tools and developer relations.
Cool. Thanks, Asa. So first, let's do some quick housekeeping items before we begin. Number one, about 3/4 of the way through, we're going to have a live poll question. So this poll will appear in the right-hand panel of your GoToWebinar screen. We encourage you to participate. It's a fun question, and we'd love to hear from you. Second, there's going to be a live Q&A at the end of the webinar, and we encourage your questions. If we run out of time, we have an email where you can direct any questions for feedback. And lastly, we'll be recording this webinar, and we'll post the video in about a week or so. So if you weren't able to tune in live, or if you want to rewatch or share with a colleague, you'll be able to do so with that link. So we have a packed agenda for today. Here's what we're going to cover in short order. We're going to start by providing some context on what's going on across industries and sort of give you the genesis of our offerings today. We'll briefly describe challenges that we've seen across our global customer base. From here, we'll introduce Planet Analytic Feeds and provide an overview of our existing capabilities. We'll showcase some use cases we've seen and then do a quick demo of the product with Asa Strong. And lastly, we'll tease a few upcoming products and then finally turn to a Q&A with your questions. So be thinking of questions throughout, and we'd love to answer them. So let's dive into some industry context. And before we really dive into the product, I wanted to spend a few minutes to help contextualize where we are right now, because we're at a particular moment in history that helps explain the why and the need for solutions such as Planet Analytic Feeds, or as I like to call it, the big now. So what is the big now that we're living in? One of the major trends over the past 5 to 7 years is the rapid increase in the amount of satellite imagery available for understanding what's happening on the planet. Once only the domain of governments and large enterprises, satellite imagery is quickly becoming a key source of big data that's being leveraged by a range of industries. And a lot of these industries do not have access or budgets needed to acquire satellite imagery. The democratization of satellite imagery is truly a beautiful thing in a lot of ways because it's enabling more people and groups to get a transparent and accurate understanding of their world. And it's really changing how people behave as a result. This explosion of satellite imagery has created what we at Planet called an abundance challenge, because today, small and medium organizations can access satellite imagery of the entire world on a daily basis. I chose this image because it reminds me of the song, "He's Got the Whole World in His Hands," because today you can actually have this power. It's not just a fanciful idea. This abundance of data has the power to completely overturn old ways of doing things, traditional analyst workflows, and even the skills and talents needed to leverage this type of data. Of course, with abundance comes its own sets of challenges. And today, it's not simply a matter of access to data, but rather activation of data to create true insights. And from a workflow perspective, that means moving away from manual, time-intensive techniques like putting more eyeballs on imagery to those automated approaches that can scale. Because for many organizations, it can be costly, time-consuming, and labor-intensive for an organization to consume this vast amount of satellite imagery over broad areas. So as a result, the imagery, which holds so much value, can get set aside for later use. And today we're seeing that many organizations also lack the in-house engineering expertise to build the sort of automated feature extraction capabilities to identify things and objects and features from the imagery itself. So our job at Planet is to help really figure out where you're spending your time and where you want to dedicate your resources. And one of the main things we observe in our customer base is this sort of restlessness over potentially missing something. We've also observed that our customers spend the majority of their time looking at the places and activities where they're expecting something to happen. This is a somewhat abstract quadrant that conceptualizes where we see our customers spending time, which is typically in areas where they need to look or where they think they need to look, and looking at a set of activities that they're expecting to happen. But on the whole, they pretty much know where they should be looking. But where we see customers spending the least amount of time, and it makes perfect sense, is anticipating locations, activities that they don't know yet about and that they need to get ahead of. So essentially, they don't know where to look next and they don't know what they're looking for, and that creates risk. Of course, every organization's risk tolerance is different, but let me make this real for you with an example. Say you're an organization trying to understand larger indicators of economic growth, and you're tracking the development of buildings in China. You have your top 10 areas where you're looking, but you don't spend any time on this particular place shown here. And meanwhile, all of this flurry of activity is happening at a much faster rate than you expected. So in this animation, what you're seeing with the blinking yellow squares, this is actually our automated building detection, and it's highlighting where new buildings are constructed month over month over the course of a year. So all of this change is happening, and you might not be seeing it. And if you focus too readily on the places you thought you knew were developing faster, you could potentially be misallocating your time, which, as we know, is very precious. So what we're here to do at Planet is help you move up the value chain and provide you with the different formats and data products you need to get to insights, whether that's the raw pixels from the bottom left-hand corner all the way up the value chain to deep semantic layers, which is where our Planet Analytic Feeds sit. And that leads me perfectly to introduce my co-host Justin Davis, who's going to introduce the product.
Thanks, Jenna. You've outlined this problem so well. Really, how can our users stay up to date with activity throughout the world when there's really only so many resources available to look at it? Our feeds deliver continuously refreshed insights from our imagery at global scale. So leveraging computer vision, our analytic feeds automatically extract the relevant objects and features from our imagery, freeing up our users to act on the information in a timely manner. And soon, no matter what particular phenomena you're interested in tracking, what particular activity you want to stay up to date with, you'll be able to do so leveraging our analytic feeds. So we started with these as our first feeds to bring to market, as we found the most broad-reaching applications with them, and they satisfied both a land classification and object detection use cases, both of which serve as the foundation of our analytic feeds. So using these features as the basis to build out our end-to-end pipeline, we now have an analytic engine built to be able to run object detection models and land classification models. So provided with an area and time of interest, we automatically process our imagery as it's published to detect roads, ships, and buildings. And in this way, our users can always be sure they have the most up-to-date depiction of these features at any given time. So let's begin with our road detection feed. These are based on our monthly visual base maps, which you may remember from Jenna's last webinar, and if you haven't seen it, definitely give that a listen after we wrap up here today. Our monthly base maps take the best imagery each month and seamlessly stitch it all together. They remove clouds wherever possible, apply a normalized color curve, which really makes it great for computer vision models to train on. And so each month, as this base map is published, we run our road detection model over it. classifying every pixel as road or not road, creating the most granular depiction of roads as possible. And this gets formatted as a geotiff. It's then made available through our Web Map Tile Service, or WMTS, and through a REST API, easily integrated into our user's workflow. And here's a quick example of what the analytics look like overlaid on top of the source imagery that was used to derive them. And this example is from the Permian Basin in West Texas. So next, our building detection. This pretty much follows the exact same paradigm as our road detection, based on those same monthly base maps, and classifying all the pixels as, instead of road or not road, it's building or not building here. It's available through those same APIs and tile services for easy integration into GIS platforms like ArcGIS or QGIS, which Asa will talk a little bit more in a few minutes. And so here's a beautiful example of our building detection in action over Cairo. So you can see how we're able to detect all of those buildings and create this analytic layer. And lastly, our vessel detection. So this one is a bit different for a few reasons. The first being that it's based on our daily PlanetScope scenes, not our monthly base maps. So since ships move frequently, while roads and buildings are largely less dynamic in nature, we decided to base our ship detection feed on our high cadence imagery. So our ship detection is focused on port activity, really only running on imagery up to 15 kilometers offshore, so people can stay up to date with what's going on in the ports of the world. And the other reason it's a bit different from our road and building feeds is that it's based on an object detection model. So instead of classifying every pixel as ship or not ship, we generate a vector bounding box around the ships as they're detected in the imagery. And each detection is formatted as part of a GeoJSON feature collection and gets delivered through our analytics API. And it adheres to the latest OGC features API specifications, which is a bit of an evolution of the WFS3 spec if you're not familiar. And so here we can see an example of our vessel detections day over day, and you can see just how much things change on a daily basis. So as with everything that Planet does, it's our global coverage and our daily cadence that really separates us from the rest. Our analytic feeds are no exception, as they're built on that same promise. Our ship detections are delivered daily, and our road and building detections leverage those cloud-free mosaics, which we're able to generate mainly because of our frequent revisits. Our scaled automation and compute platform makes it so that you don't need to worry about running any operations. We take care of it as soon as imagery is available, so you can continue focusing your efforts where they're needed most. The less you need to worry about data preparation and transformation, the more you can bring your unique expertise and industry knowledge to get the answers to your most pressing challenges. So let's talk about our archive just a little bit. So since completing Mission 1 in 2017 to image the Earth's landmass every day, we've been collecting global imagery on a daily basis. It's this archive advantage, the deep stacks of imagery, that has enabled us to train these models, which crave that sweet, sweet training data. But maybe more importantly for our users, it means that we can run these models over 3 years' worth of daily data to generate patterns of life and baseline activity. We can use all of that data to find trends, identify anomalies that require further investigation. It's all to help point you to where your resources and attention are most needed. So we've covered how we've been able to tackle the data from a temporal aspect. What about spatial? Well, let's take a look at this. Here we are. So this is a view you might expect to see if you opened up your phone and wanted to get direction somewhere. And here is our monthly base map overlaid on top of it. You can see how we've been able to remove clouds and stitch together all of that imagery seamlessly. And here, if we have no technical difficulties, we should be able to see our roads and buildings overlaid on top. So hopefully you're able to see this video right now, which is a little laggy for me, where you can see our entire global roads and buildings run. We've been able to extract every road and every building across the globe. So no matter how remote of a location you're interested in, you'll be able to see the most up-to-date roads and buildings. And because this is based on our monthly base map, we can refresh this on a monthly basis. So you'll always have the most up-to-date depiction. And with that, I think it's time we talk about use cases of our three flagship analytic feeds. So let's take it away to Jenna.
Thanks, Justin. So let's dive into some use cases that we're seeing across our customer base. And we're going to start, we're going to take you to Wyoming, because for about a half a century, the Powder River Basin, which is about 20,000 square mile region in northeast Wyoming, has served as the state's economic engine. The base continues to lead Wyoming in oil production and contributing to about half the state's oil output. And this trend shows very few signs of slowing down, making the basin really a key place of interest going into 2020. So what we decided to do was run our road detection over the Powder River Basin. And what you're seeing here is an actual zoom-in view of some new roads that have developed over the course of last year. Because what we've found working with energy companies is that roads are often an indicator of when a well pad will be constructed. And roads are also a good macro indicator of where that development is going to be concentrated. And so you'll see here, these are each monthly detections over the course of last year, where you'll see that different stages of the well pad are constructed from about February through July. Of course, this is a pretty big close-up of just a single well pad, and so we wanted to give you a sense of the overall county. And what you'll see here is that lots of roads are developing month over month. So I'm going to go back and forth between June, July, and August to give you a sense of the change taking place. And you'll also notice, particularly in the upper left-hand corner, where those well pads are coming in. So let's move to a different region, a totally different region of the world, outside of Dubai, because there's really no place on Earth that has had as much drastic land cover change over the past decade as Dubai and the United Arab Emirates. Dubai has led to the creation of over 300 kilometers of coastline. They've seen rapid expansion of urban land cover and, of course, intensifying that urban development. So it makes it one of the most rapidly and visibly changed land masses due to urbanization. And, of course, that growth is not expected to slow down. And, in fact, if you just look at this side by side between 1990 to 2015, you'll see the kind of massive changes that this place is undergoing. So it's really a perfect candidate for our building detection because understanding where buildings are being constructed really is going to be critical for governments and organizations to kind of properly route resources and public goods. So what we did is we ran our building detection over an outerlying area. It's a different city. It's Sharjah, but this is where a lot of expansion is happening from the coastlines more inland and south and north of Dubai. So Sharjah is actually one of the third most populous cities in the United Arab Emirates. And what you're seeing here is a December 2018 mosaic where we ran our building detection over it to give us a baseline of what has happened over the year. And then we compare it to December 2019, and I'm going to toggle back and forth so you can kind of see that new buildings are coming into creation over that year period. And what we really noticed is a lot of construction concentrated in this area. And so after we ran this detection, we actually queued up a SkySat satellite to give us a higher resolution view of what was going on. And what's interesting is that we discovered that this building here is a new building called the House of Wisdom, which is this immaculate library that they're constructing or have been constructing over the past year, and it's scheduled to be to open actually in April of this year. And we were able to actually capture that, getting a signal from the building detection and then tasking the satellite to get a closer view into that area of change. And so what we see our building detection is really complementary with our other satellite offerings at Planet, and think that like Justin indicated earlier, this is a way to focus people's attention. And lastly, let's move over to a totally different part of the world, the port of Bandar Abbas in Iran, which is located on the Strait of Hormuz, where a lot of, basically a big majority of the world's oil travels through this strait. And so it's of particular interest now, too, because the U.S. imposed sanctions on Iran in 2018. And so a lot of people are looking at this port to kind of get a sense of not just the levels of activity, but also any, abnormalities or anomalies. So what you're seeing here is just a PlanetScope image over the port. And this is kind of a good representation of what you might see in medium resolution. But with automated, vessel detection, what you're going to get delivered is these bounding boxes that really help highlight where the ships are located in port. And not only that, you'll be able to kind of count and get quantities of those ships. And because of our daily cadence, you'll be able to get multiple detections day over day. So I'm going to toggle back and forth between September 24th through the 26th. So you can see that every day there's movement with new ships coming and going. Great. And I think with that, I'd actually like to move us into the product demo section. So I'm going to pass the mic to Asa Strong, and he's going to give you a good sense of the capabilities of bringing our analytics into GIS platforms. Asa, take it away.
Thanks, Jenna. Thanks, Justin. Today, I'd like to show a quick demonstration on how Planet Analytic Feeds can be accessed inside of popular GIS systems in order to further refine the data to create more actionable insights. Planet maintains integrations with some of the most popular GIS systems out there, like QGIS and ArcGIS. So here we're going to take a look at ArcGIS Pro, and we're looking through the Esri Living Atlas of the World, which is a curated catalog of some of the most premier data sets. We've pulled in a live stream gauge data set, which is maintained by USGS and NOAA, and shows us where minor to major floods are located across the world. If we zoom into a location of a major flooding event near Hyderabad in India, we can further inspect this location by pulling in the January of 2020 base map published by Planet. Looking around the base map, it's a little bit difficult to make out where the buildings are located in this landscape, which is a really important feature to be able to identify in location to a major flooding event. But if we pull in the Planet Analytic Feeds, we can really quickly start to make out where these buildings are located and which are in proximity to the major flooding location and are potentially at risk of flood impacts. The Planet integration with ArcGIS Pro also lets you download these analytic feeds. So selecting the Download Base Maps tool, we can actually pull out the different base map quads that make up this analytic feed. We can see here that there's 4 of them, and they equal almost 300 square kilometers. I've already downloaded one of these base map quads, and zooming into this location, we can see how much easier it is for us to pull out the different infrastructure points located around this major flooding event. We can also further refine this data using different models and geoprocessing tools inside of ArcGIS to transform it into a data layer that's even easier to use inside of GIS processing tools. Many of our users like to work with points, for example. So this particular model builder application will convert that raster data into a points center points data set that is showing us where the infrastructure locations are. And if we compare this to the OpenStreetMap data, we can see that some of these locations are mapped, but many of them aren't. And those areas that haven't been mapped by OpenStreetMap are particularly concerning because we want to make sure that all the communities are considered when having a response to a disaster like a major flooding event. The power of GIS really lies in the ability to combine multiple data sets based on their commonality of location. So we can pull in something else like the terrain layer from the Living Atlas of the World, which is going to show us the slope in this particular region. And if we run these points through another model, that will pull out the points that are intersecting the strongest sloping locations, we can further pinpoint areas that might be at risk of a catastrophic flood. Once we run this model, we can actually take a look at the different infrastructure points shown here in red that are at risk of a flooding event and are also intersecting really strongly sloping landscapes. This has showed us how we can bring the Planet Analytic Feeds into GIS, further refine it to create insights that are a little bit more actionable for decision makers.
Cool. Thank you, Asa. That was wonderful. Next, I'm going to pass to you, Justin, because I think you have a little preview that you want to talk about and entice our audiences with what's coming up next.
Absolutely. So as I mentioned, our roads, buildings, and ships are really just the beginning. And in just a few weeks, we're going to be launching 3 new feeds. The first being plane detection. So similar to how we use ship detection to keep tabs on port activity, we'd be able to use plane detection to do the same thing with airports and airfields. So really keeping track of just how many planes are in each airfield, each airport over time. The next is well pad detection. So folks really want to know when a new well pad has been cleared. This can help with permitting, inventory management, and many other applications in the energy market. So we'll be releasing a well pad detection feed as well. And then in addition, we're going to have a silo bag detection feed. So silo bags are basically in the same way that you can store grain in stationary silos. These are bags that will store crops and grain just out there on the field. And so we're able to detect these, and this can help commodity traders maybe make more informed decisions about when they want to make a trade or maybe not. And so really, we're going to continue to extract these key features from our imagery as it gets published and make it available. If you can see it in our imagery, we should be able to create a feed around it.
Great. Thanks, Justin. Okay, so before we head into the live Q&A, we'd love to get your engagement on this poll. So let me go ahead and launch the poll. Great. So the question is, which of the following best describes your organization's pursuit of machine learning powered analysis? And so what we want to do with this question is really understand sort of what stage in the process you are in looking at these types of solutions, whether it's just sort of an exploratory phase, if you're already building this stuff in-house, if you're looking at commercial solutions, or if that describes none of it, we also want to know. Cool. Let's give people about 10 more seconds to answer. Justin, what do you think the most popular response will be?
Oh, who knows? Let's see. Probably exploring different options. It's a relatively new capability. So people are probably weighing what they can do.
Yeah, I think so too. Okay, let's go ahead and close the poll. Okay, let me bring up my slides again. Yeah, I think that makes sense, right? This is very kind of bleeding edge, cutting edge technology. I think most people's workflows are set up to do sort of manual analysis. And so it makes sense that they're just sort of looking into this, but not actually kind of building yet or evaluating yet. But what we hope to do with this webinar in part is to kind of get people to see that some of these things can be purchased off the shelf. Okay, so now let's move to live Q&A. We got your feedback on the poll, which is great. Now we're going to be looking for your questions. So start uh, submitting those, and we're going to kind of try to sort through those now and answer as many as we can in the time that's left. Okay, so we have our first question. It says, and Justin, I'm going to point this one to you.
Excellent.
So it says, I'm interested in an object other than what's been featured so far. When will other object detection models become available?
Awesome. Okay. So, I mean, I kind of touched on it a little bit with the next 3 feeds that are going to be released in just a few weeks with plane detection, silo bag detection, and well pad detection. But really just want to double hit this. We've really spent the last couple of years developing an agnostic infrastructure that can run, like, it doesn't matter what feature you're really looking for. We can run an object detection model or a land classification model that can automatically detect those features. So really, if you can see it in the imagery and it takes like less than a second for you as a person to recognize that's the thing that you're looking for, we can train a model to be able to detect it. So really, I'd love to hear from all of you what those features are that you're looking to detect, because we're always looking for more things to develop.
Yeah, that's great. And I think for people listening, if they do have an object or feature that they're looking to automate, detection of, just reach out to us. We're going to throw up our emails at the end. But please reach out. We'd love to hear from you. Okay, so we have our second question. It says, can the vessel detection feed tell me what type of ship it is? So they're looking to classify ships, I think.
Sure, that makes sense. So right now, our vessel detection feed is saying if there is a ship there and where is that ship. We're exploring classification a little bit. It is something that we've heard, but as of yet, not something that we focused on. So one piece of metadata, though, that could help, we provide the diagonal length of the bounding box, and we have found that to be a pretty good proxy for ship length. And so based on how big the ship is, there's some things you can glean from that. But at this point, it is pure ship detection and not classification just yet.
Got it. And of course, if you buy the vessel detection, you get access to the underlying imagery, which may give you other contextual details about the vessel type, along with, just that it is a ship out at port.
Exactly.
Cool. Okay, we have another vessel detection question. The question is, it says, can you do open water vessel detection?
Yeah. So, I mean, right now we focus the model on detecting ships in port, and we can go up to 15 kilometers offshore. So while we do detect some ships that's basically surrounded by water, we do stay within that 15-kilometer range off of shore.
Gotcha. Okay, cool. We have a question here about performance of our models. So it says, do analytic feeds perform the same across every location of Earth, or is there variance?
Yeah, good question. So our models, they've been generalized as much as possible to work on a global scale, and they've been tested and tuned based on specific AOIs that, I mean, we've tried to be as representative of what features there are across the planet. So we've really focused on exposing the model to all sorts of different terrains and different types of water. In the case of ship detection, you have no idea how different the ocean can look, or maybe you do. But really, what we found is that different customers have sort of different use cases and different requirements around what they're really trying to do with these feeds. And the best way that we've seen, at least so far, has been giving customers trial engagements so that they can see just how it performs, where they're curious about, where they need it. And then from there, they can figure out whether it's fit to purpose or not for them. So that being said, I mean, of course, we've done our own analysis. We've really looked at how it performs and where. So we know more or less what to expect from the models. But like, for example, our road detection is like really good in urban areas and a bit better than it performs kind of in dense forests. But where rivers can sometimes be detected as roads. But really, I mean, even in the forest, we've seen some really good use cases. Like you were talking about where a road being developed leads to a well pad clearing. The same thing can be said for deforestation. So even the places where it might not be as high performing as in other places, we have seen some really good use cases and applications of it.
Great. Yeah. Cool. Here's one specifically about the formats of the output. So it says, I saw that outputs for roads and buildings are rasters. Do you provide vectors?
Yeah, so true. Our road detection and building detection output is raster. For every single pixel, we classify them as road, not road, building, not building. So the format has been a geotiff. So I mean, ASA showed a good example of using GIS tools if you really need it in that vector format. There's lots of tools that can help with that. We've really so far focused on really providing the most granular depiction of where the roads and buildings are. And we haven't really focused on productizing the vectorization of these base layers. We really are choosing to focus on really trying to figure out where the changes is taking place. So we've been working on developing a change detection feed, so keep an eye out for future webinars about that. And really for detecting change, the raster output has proven to yield better results. But to the question poser's point, we have gotten a lot of feedback from our users that vector output would be beneficial. We know people want to label different polygons, different lines, and maybe they want it to be a smaller data shape that they can work with. So we have put together some sample code, some sample notebooks that can show you how to leverage our feeds and run some straightforward GDAL operations. And actually, let me plug our developer center really quickly. So at developers.planet.com, you'll find a lot of really good getting started guides that are focused on working with all of our APIs, including our analytics. And you'll find a lot of really good Jupyter notebooks there to help get you started as well.
Great. Cool. I think I'm just going to take this last question. And of course, as I said before, we're going to wrap up after this one. And you can, of course, send and submit any more questions and we'll get back to you. And of course, the last question I want to take is, I'll answer it. It's what's the pricing for analytic feeds? We get this one a lot. So what we do, or how we've approached analytic feeds at Planet is really as a value-added capability on top of the core imagery products. So whether that's the Planet Scope monitoring solution where you get that daily refresh, or if it's Planet Base Maps, which is our monthly, quarterly, weekly mosaic. So what that really means is that you're going to purchase the underlying imagery, and then we pair it with analytic feeds. So the feeds are kind of extracting from the imagery. So let me give you an example. With road detection, you pay a single price that includes both the base maps and the road detections together. So it's basically a bundle. Of course, if you're interested in getting the exact pricing, of course, feel free to reach out to our sales team, sales@planet.com. They'd love to get a better sense of what you're trying to accomplish and how we can help you, and of course, provide pricing when appropriate. Okay, I think there's probably lots of other questions that we could address, but I want to be respectful of people's time. So let's wrap up with next steps. First, of course, if you want to learn more about Planet Analytic Feeds, take a look at our website. There's a lot of good information on there to just get you introduced further. What we've done in the right-hand panel is there's a handout which you can download. It's a data sheet that basically provides much of the same information that we gave on this webinar, but it's more condensed and easily shared among different people in your organization. Justin mentioned this earlier, but we are also going to be making available free demos or trials. So we just encourage you to contact our sales team and they can learn more about your use case, and then you can kind of get a sense of how the feeds work and the formats to the areas that you care about most. And of course, lastly, Justin teased this, but this is really the first in a series, and we'd love to have you tuned in for upcoming webinars on new analytic offerings, including things like change detection. So please just stay tuned. Look for our emails and newsletters and social, and we'd love to see you there. And with that, I think we are about done. Of course, thank you so much for attending. It's been really fun working with Justin and Asa on this. And of course, if you have questions, you can reach out to both of us directly, and we'll do our best to either answer or put you in touch with the right people. And that's all. Thank you so much for tuning in, and we'll be in touch soon.